Okay, class, we're starting on section 4.6, Order of Operations on Fractions. Section A, Order of Operation Problems. Parentheses or other grouping symbols that have operations inside them. Exponents, actually this is number 1, which is parentheses. Number 2 is exponents. And watch out for negative numbers and fractions. Remember that parentheses around either of these makes a big difference in the results. And then we have number 3. Number 3 is both multiplication and division, whichever one comes first from left to right. And then number 4 is addition or subtraction, whichever one comes first from left to right. Now, that's a brief overview of the order of operations. Now we go here to our examples. Now, look at the operations we have. We had division, and we also have parentheses here. So we do what's in parentheses first. We will have 1/2 minus 1/6. So now we need to find a common denominator. So what we would do is we would do the prime factorization of our denominators of 2 and 6. 2 is already prime, and 6 breaks down to 2 times 3. Now, to do our least common denominator, this is what we would do. We will look here and see that we have these two 2's that match up, so we write it once, and we have a 3 left over. So our LCD is actually 6. So our least common denominator here would be 6. Now we say 6 divided by 2, new denominator divided by old denominator. 6 divided by 2 is 3. So we'll multiply our numerator and denominator by 3. Here, 6 divided by 6 is 1. So we multiply our numerator and denominator by 1. 3 times 1 is 3. And we know 3 times 2 is 6. 1 times 1 is 1. And 6 times 1 is 6. Now we add 3 6 minus 1 6, which will give us 2 6. Now we can simplify this. This breaks down to 2 over the prime factorization of 6 is 2 times 3. These two simplify, and that would leave you 1/3. So this parenthesis leaves us 1/3. So now we will go over here. We would take this 3/4 divided by the 1/3 we got from this parenthesis. Now we will keep this fraction the same. Division will become multiplication, and we'll take the reciprocal of the second fraction, which means that we flip it over. So now we multiply. 3 times 3 is 9, and 4 times 1 is 4. They have nothing in common, so our final answer is a positive 9/4. Okay, now we go to problem number 2. Now we have division and multiplication. Remember, this is step 3, whichever one comes first from left to right. So we'll start off with the division. So we'll take 2/3 divided by 4/5. Now 2/3 remains the same. Division becomes multiplication, and we take the reciprocal of 4/5, which is 5/4. Now we would take the prime factorization of these numbers. 2 is already prime, and 5 is prime. And our denominator, 3 is prime, and 4 breaks down to 2 times 2, because we know the prime factorization of 4 is 2 and 2. Now we can simplify out these 2's, and we'll be left with 5/6. So now we take this 5/6, and we multiply it by this 3/5. Now we would take the prime factorization. 5 is prime and 3 is prime. 6 prime factorization is 3 times 2, and 5 is already prime. These 5 simplify out, these 3 simplify out, and so your final answer here is 1/2. Now we scroll down here, or actually we go to the next page with our examples. Now again, we look here. We have our parentheses. We have 1/2 minus 1/3. So we do that first. So we have 1/2 minus 1/3. Now we already know that 2 and 3 is prime. Whenever both of your denominators are prime, you could just multiply them together, and that will give you your denominator, which here would be 6. Now we would take 6 divided by 2, which gives us 3. So we'll multiply the numerator and denominator by 3. And 6 divided by 3 is 2. So we'll multiply the numerator and denominator by 2. 3 times 1 is 3. And 1 times 2 is 2. 3 6 minus 2 6 will give 1 6. Now remember, this 1 6 would be in this parenthesis and it's squared. We know we would do the exponent before multiplication. So why don't we just square this? So 1 6 to the second power is the same as 1 6 times 1 6, which would give us 1 over 36. Okay, so now that would take care of this parenthesis and the exponent. So now what we would have is we would take this 36 times 1 over 36. Now, this is the same as 36 over 1 times 1 over 36. Now, we don't have to do the prime factorization of this because this would give us 36 over 36, which is just 1. So our final answer here is 1. Now we go here to number 4. Again, we look inside this parenthesis. We can't do anything inside of this parenthesis because it's already factored and it's down to its lowest terms. Now here we have another exponent and we also have subtraction. So we would do this first exponent. 3/4 to the second power is the same as 3/4 times 3/4. And we could bring down the rest of this. 3/4 times 3/4 will give us 9 over 16 minus, we know 5 to the second power is 25 over 6. Now we need to find the common denominator of 16 and 6. So we could go off here up top and we could take 6, which breaks down to 2 and 3. And we could take 16, which breaks down to 2 and 8, 2 and 4, and then 2 and 2. Now if we look here, this has 4 2's and this has a 2 and 3. We have one set of 2's that match up. So we know what our LCD, actually I didn't give myself enough room here. Let me write it over here. Our LCD would be equal to, we have one set of 2's that match up, and then we have 3 2's that are left that we write here. So that'll give us 4 2's and we have 1 3 left. So our LCD would be 48. So that what our new denominator would be, which would be 48. Now again, we would take 48 divided by 16, which is 3. So we'll multiply this numerator and denominator by 3. And then 48 divided by 6 is 8. So we'll multiply our numerator and denominator by 8. 3 times 9 is 27. 25 times 8 is 200. And we know our denominator is 3 times 16 is 48, and 6 times 8 is 48. 27 minus 200 will give us a negative 173 all over 48. And this right here is our final answer. They have nothing else in common. Also, class, one other thing about this problem. I want to clean up one thing that I did here. When I did the prime factorization of 6 and 16, I should have just wrote it out, you know, the way how we commonly did it. So we know the prime factorization of 6 gives us 2 and 3. And then the prime factorization of 16, we know gives us these 4 2's. This is just to keep consistent. So I just do this here, and we did all the work for it up here. Okay, now we know that these two match up. So when we do our LCD, we'll mark one of them. Now there's nothing else that matches up, so we'll bring down these 3 2's that's left. And then we have this 3 that's left as well. And this is how our LCD is 48. I just want to clean that up because I didn't do it as clean up here. So your answer is still a negative 173 over 48. Now we scroll down here to section B, evaluating expressions. When working with fraction, it is a good idea to use parentheses around the fraction when you substitute it into the expression. Remember that this was true for negative numbers also. Now we have evaluate x squared minus y. Now they tell us x is 2/3 and we square it, minus y is a negative 1/4 and we put that in parentheses. Now we would take 2/3 squared. We know 2/3 squared is the same as 2/3 times 2/3, then minus this negative 1/4. 2/3 times 2/3 would give us 4/9, minus a negative 1/4 would be plus 1/4. Now we need to find a common denominator of 9 and 4. So we would do this. We would find the prime factorization of 9 and 4. This is 3 and 3, and 4 is 2 and 2. Now if you notice here, we have no numbers that match up. So the LCD would actually be all of these numbers. So we would have 2 2s and 2 3s. So our LCD would be 36. So our new denominator would be 36. Now, again, we take the new denominator divided by the old denominator. 36 divided by 9 is 4. So we multiply our numerator and denominator by 4. And then 36 divided by 4 is 9. So we multiply our numerator and denominator by 9. 4 times 4 is 16. And 1 times 9 is 9. So 16 over 36 plus 9 over 36 is 25 over 36. And that is your final answer for that problem. Now we go here to number 2. We have y is 5/9 plus 2 times x is 7/12. Now, you notice that I substituted in parentheses, which you're supposed to always do. So we bring down our 5/9, because there's nothing we can do in here, and there's nothing multiplied or squared to it. And then plus 2 times 7 over 12. Remember, this is the same as 2 over 1. So that would give us 14/12, because 2 times 7 is 14, and 1 times 12 is 12. Now, we could do a couple things here, but I think what I would suggest first is, why don't we simplify this 14/12 first? Okay, we could go up here because we have this space. You have a little bit more space on your paper than I do. So this is what I'm going to do. I'm going to take 14/12, and I'm going to take the prime factorization of 14, which we know is 2 and 7, and the prime factorization of 12 is 2, 2, and 3. These 2's will simplify out, and that will leave us 7, 6. So we have 5/9 plus 7, 6. Now we need to find the common denominator of 9 and 6. So we go here. We'll take 9, which we know is 3 and 3, and we'll take 6, which we know is 2 and 3. These are their prime factorizations. Now we do the LCD. Now, first of all, we bring down our 2, and we have one set of 3's that match up, so we bring that down once, and now we have another 3. So now, when we multiply, 2 times 3 is 6, times 3 is 18. So our LCD is 18. So both of these denominators will be 18. Now 18 divided by 9 is 2. So we multiply our numerator and denominator by 2. And then 18 divided by 6 is 3. So we multiply our numerator and denominator by 3. Now we have 2 times 5 is 10, and 2 times 9 is 18. 7 times 3 is 21, and 6 times 3 is 18. 10 plus 21 is 31 over 18, and they have nothing in common, so we can leave it as this. Okay, class, with these last two problems, we have complex fractions. We have a fraction divided by a fraction, which I rewrote with the traditional division sign. So we had 3/4 divided by 7/8. We write the 3/4, division becomes multiplication, and we take the reciprocal of the second fraction. We break these down to their prime factorization. 3 is prime, 8 breaks down to 3 2's, 4 breaks down to 2 2's, and 7 is already prime. We had 2 sets of 2's that simplify out, and 3 times 2 is 6, and we also have 7 in our denominator. Number 2 is the same. We rewrote the fraction. We took 3/5, changed division to multiplication, took the reciprocal. All these numbers are prime, so they had 3's in common, and we're left with 7/5. And that is your final answer.